In this lesson, we're going to look at a more complicated trig equation where we have to use the double angle formula. So solve the equation cos 2x equals cos x, where 0 is less than or equal to x is less than or equal to 2 pi. So we can see here we're going to have to answer in radians, and we've got a substitution to make. So first things first, what I would do is get everything over one side and let it equal 0. So we take away the cos x, let it equal 0, and then think what we have to substitute in here. So let's get our formula. So we've got three options again. We can discount the top one because that's not really going to help us introducing cos and sine into this. What we're looking to do is make everything the same here. So we've already got cos x here. So the substitution you're looking for is the one with the cos in it. So it's this one. So we'll substitute that in. 2 cos squared x take away 1. And then we'll rearrange this into a trinomial form. So that means we want a square at the start, an x value in the middle, and then a number at the end. So like that. So instead of taking a common factor like the previous examples, we now need to do double brackets. So at the front of the double brackets you need a 2 cos x and a cos x to make 2 cos squared x. It's just like 2x times x makes 2x squared. So this time we're going to have 2 cos x and we're going to have cos x. Now at the end of the bracket there only is two values that multiply to make 1, and that's 1 and 1. Okay, so we've got 1 here and we're going to have a 1 here. The last part we need to get the signs correct. Now it needs to be a plus and a minus to make a minus 1. So you have to get it the right way around. So if you were to put a plus here and a minus there, that's going to give me a minus 2 cos x, and this is going to give me a plus cos x, which is going to make negative 1 cos x. So that's that there. So that's correct. If you did it the other way around and you put a takeaway here and a plus there, then you're going to get a takeaway cos x, but this is going to give you 2. So it's going to be 2 cos x take away 1. That's going to give you plus cos x, so that can't be right. So that's a takeaway and that's a plus. Once you've done that, we're in the same situation as before. Either that equals 0 or that equals 0. So let's have a look at that. So the first one here, then take away 1, divide by 2. So cos x is equal to negative a half. The second one, cos x equals 1. So if you think of the cosine wave, it starts up top and down, dips down and back up top. At the start and end you're looking at there, so that's 0 and 360. On this side of things, you want to find your acute angle first. Now your acute angle is inverse cos of positive a half, because we want the first quadrant answer. So first quadrant answer is going to be inverse cos of a half, and that's going to be 60 again. But cosine is negative here, so we don't want the first quadrant answer, we want where cos is negative. So that will give us the sine quadrant, so that's back 60 from 180, and that's going to be 120. And then we also go into the third quadrant, so that's forward 60 from 180, and that's going to be 240. So there's your solutions: 0, 120, 240 and 360, but we have to convert these into radians. So to convert into radians, multiply by pi and divide by 180. So multiply by pi, divide by 180 in each case. Now the easiest way to do this is to divide by 45 normally. In this case, 45 doesn't go into 120 or 240. It will go into 360 though. So in this case you might want to get rid of the zeros like this, and then divide. So we cancel down, well, 0 becomes a 0, we cancel down 12 over 8 to get 2 over 3. You cancel down 24 over 18 to get 4 over 3, and you have pi obviously, and you cancel down this and you're going to get 2 pi.